Hello everyone, welcome to the preparation series of GATE Computer Science, UGC NET Computer Science and Bank IT Officer exam. In these preparation series, we bring to you previous year questions solved subject wise from various computer science competitive exams, and these questions will help you in further preparations if you are preparing for any of these exams or any other competitive computer science exam that has some common subjects. Alright, so starting with today's first question of the lecture, the question says that the graph shown has 8 edges with distinct integer edge weights. The MST, that means the minimum spanning tree, is of weight 36 and contains the edges AC, BC, BE, EF and DF. The edge weights of only those edges which are in the MST are given. The minimum possible number of weights of all 8 edges of this graph is. Okay, so you are given the weight of those edges that are present or that are a part of the minimum spanning tree, but the remaining edges like ED, CD and AB are not given, or their weights are not given, and you have to tell what is the minimum possible sum of the weights of all the combined edges. So we know that the current weight of the MST, or the sum of the edges in the MST, is 36, and if we find the weight of AB, CD and ED, then we'll get our answer. Alright, so one thing you need to remember, that a MST, a minimum spanning tree, has all those edges that do not form a cycle and that are minimum weight edges that connect a vertex that is not present in the set of vertices that are already included in the MST. Alright, so if we look at this A, B and C cycle, then we see that in the MST which edges are included? AC and CB. The edge AB is not included. This ABC forms a cycle, and if we are not including one edge from this cycle, it means that this edge must have been the highest weight edge, because we need all the vertices in the MST, and therefore we would need A as well as B as well as C, and the minimum number of edges that would be required to connect 3 vertices to other vertices of this graph would be two edges. Okay, so we would have to choose any 2 edges between AB, AC and BC, and since it is a minimum spanning tree, we would choose the minimum weighted edge. Okay, and the 2 edges that are selected are AC and CB, therefore these would have been the minimum weighted edge. Thus we can without any doubt, or we can clearly say that the weight of AB must have been greater than the weight of the highest or the maximum weight edge out of AC and CB. Okay, so weight of AB must have been greater than the max of the weight of AC and the weight of BC. Alright, and what is the max out of 2? The max out of 2 is 9. Therefore, we can say the weight of AB must have been greater than 9, or we can simply assume it to be 10. And why we have assumed it to be 10 and no other value? Because we have found, or we have to find, the minimum possible sum of weights of all these edges. So the minimum weight that is greater than 10 would be the minimum weight that is greater than 9 would be 10. Okay, now similarly, if I consider this cycle, the cycle E, F and D, we can simply, or we would write the same the same for this cycle also, that the weight of the unweighted edge ED would be greater than the max of the 2 edges that are given, 4 and 6. 4 is the weight of EF and 6 is the weight of DF. Okay, so if these are the edges that are minimum out of the three edges ED, DF and EF, then definitely weight of ED would have been greater than the max of the two, which means this weight would have been greater than 6. Thus we can say weight of ED would have been 7, or we can safely assume the weight of ED to be 7. And on similar grounds, if we have said that this is 15, this is 2, and this is the edge ED, we have assumed it to be 7, then CD would have been greater than 15. Okay, so because 15 is an edge that is chosen over the edge CD, thus this edge CD would even weigh more than the edge that has been selected in the minimum spanning tree. Alright, so we can assume that the weight of CD must have been greater than 15, and therefore we are assuming it to be 16. Alright, so the sum of all the edges would be the sum of the edges that are present in the minimum spanning tree, that counts, or the sum is equal to 36 plus 10 plus 7 plus 16. Alright, so this would give you a total of 36 plus 33, and that comes out to be 69. Alright, so that's how you'll calculate what can be the minimum possible sum of weight of all the 8 edges of this graph. Alright, and you can write this answer here because it's a numerical type of question. Now coming to the second question of this lecture, the question states that let G be a connected planar graph with 10 vertices. If the number of edges on each face is 3, then the number of edges in G is. Alright, this is also a question from GATE 2015, and you have to remember certain formulas for this question to be solved very quickly. See, you know that by Euler's formula you can say that by Euler's formula we know that the equation V minus E plus F is equal to 2. And what does VEF stand here? V stands for vertices, E stands for edges, and F stands for faces. Alright, so since you are given that the number of vertices are 10, alright, and you are also given that the number of edges on each face is 3. Number of edges on each face is equal to 3. Now, apart from this relation, you must remember that every edge is shared by two faces in a connected planar graph. Okay, I'll write it down for you that every edge is shared between, or it is shared by two faces in a connected planar graph that is given to you. Therefore, by the above two lines, you can safely assume the relation twice the number of edges is equal to thrice the number of faces. Okay, because each edge is shared by two faces, and each edge, the number of edges on each face is 3. Alright, so this is relation number 1. This is the second relation that we have obtained, or that we actually can derive and know. And now if we equate both these relations, we'll get the desired answer. We have to find the number of edges. So if I write F from 2, I can write F as 2e by 3. Alright, and if now I put this equation in 1, this is equation 3, and if I put 3 in 1, I'll safely get the value V is 10 minus E plus F is 2e by 3 equal to 2. Alright, so this is equal to 10 minus 3e plus 2e by 3 equal to 2. this is equal to 30 minus E equal to 6, and E is equal to 24. Alright, so E equal to 24 is your answer, or there are 24 edges in a connected planar graph which has 10 vertices, and the number of edges on each face is 3. Okay, so that is how you will solve these two questions. These were not very difficult questions, but yes, you need to understand the basics of each concept that is taught to you in such type of subjects like data structures. You have to know the concept behind a minimum spanning tree and the faces and the relation between the edges. Okay, so that's all for this lecture. I hope you understood both these questions. Please let us know in the comment section below how did you find this video, because your feedback really helps us to improve our content. Subscribe to the channel of Easy Engineering Classes for more such lectures in our preparation series, and press the bell icon to get the notifications of more videos that we upload in future so that you don't miss a video. Thank you for watching. Stay tuned. Good luck.